Welcome to a video on factoring cubics. So we've got two goals today. We're going to factor out a common monomial, and a monomial is a one-term polynomial, so one thing. So we're going to factor out a monomial out of a polynomial, and then in general factor polynomials. So we are only going to deal with cubics because that is what we're working on in Module 3. So let's talk about factoring out a monomial. The directions are only going to say one thing: factor each completely. Okay? So first thing you want to do is see if they have a greatest common factor. So in A, these all have an x in common. So if they all have an x in common, I'm going to take out and factor out an x from everything. If I take an x away from x cubed, I have x squared left. If I take an x away from my middle term, I've got negative 4x. And then if I take x away from your negative 5, you have a negative 5. So step 1, we factored out a common monomial. Now, if you'll remember from Module 2, I have a quadratic. We know how to factor a quadratic with 3 terms. We like to use the t-chart. So let's do our t-chart again. Since my a is a 1, I can do a nice little shortcut here. My a times a c goes on the left side of the t-chart. So 1 times negative 5 is negative 5. And then my middle term b is negative 4. So in the t-chart, I'm asking what's going to multiply to get negative 5 and add to get a negative 4. 1 times 5 is the only thing that multiplies to get 5. But to multiply and get a negative, 1 has to be negative, and a negative 5 and a positive 1 will add to get a negative 4. So that is my solution to my t-chart. So what we're going to do, this quadratic expands into its 2 parentheses that I found in my t-chart. So one is x minus 5. My other one is x plus 1. And then the x that I factored out at the beginning just drops down. And so you now have factored your polynomial cubic. So that looks like factored form, which we can immediately tell our answers, our roots from, which is the next lesson, so I won't get there. But we're done. So moving on to B. I've got 12y cubed minus 3y. So first I'm going to find the greatest common factor. What do these have in common? I know a 3 can go into a 12, and then they both have a y in common. So my greatest common factor is a 3y. So I'm going to factor that out and divide everything by a 3y. So 12 divided by 3 is 4. I'm going to have y squared left over, because I had 3 and I took away 1y. Bring down your minus. 3 divided by 3 is going to be a 1, and a y divided by a y is gone. So I'm going to have a placeholder of a 1 right here. So now, in parentheses, it is still a quadratic, but it looks a little different because I don't have a middle term, I don't have a b term. This is called a difference of squares. And it is a shortcut. So difference of squares appears when you have a negative, hence difference, and then a perfect square, 1 and 4. So when you have a difference of a square, we're going to square root our numbers. So let me show you. This parenthesis will split into 2. The square root of a 4. So if I square root the 4, I would get a 2. And then if I square root a 2, for my y, it would just be 1. So each parenthesis is going to get a 2y, because the square root of 4 is a 2, and a y will get you to a y squared. Now, your problem has to have a plus and a minus for difference of squares. And then the square root of a 1 is just a 1, so 1 and a 1. So that is how you solve a problem with difference of squares. Your final answer is just to drop down that greatest common factor of 3y. okay? So if you see a 2-term quadratic with a minus sign and these are positives, square roots, positive perfect squares, square root them. Let's do one more. All right, let me see what my greatest common factor. I know 5 will go into all of these, and then that last term has a C. They all have a C, so 5C. Let's factor out a 5C. So 5 divided by 5 is a 1, so I just have a C squared left over. 30 divided by 5 is a 6, so positive 6, I've got 1C, because you had 2 C's and you took 1 away. My last term after dividing will be a positive 9, and then I do not have a C with this term because I took it away. Now again, this right here is a quadratic. I have 3 terms, so to factor that further, I have to come over here and do the t-chart. Okay, so just looking at this answer, I've got a value of a 1, so it's a nice little shortcut. A times C would be 1 times 9 is 9. Then your B term is a 6. So I'm going to ask myself what multiplies to get 9. The only thing is a 3 times a 3. And a 3 plus a 3 works out to get you to a 6. So now, this quadratic is going to split up into 2 parentheses. I'm going to put both my factors in them, x plus 3, x plus 3. And then I'm going to drop down my greatest common factor of a 5C. Now, I've factored this completely, but in the last module, this, if you remember, is like a multiplicity. I've got 2 of them. So if I want to compact it further, I can say I've got x plus 3 squared, because I have 2 x plus 3 terms. So again, you're not wrong if you leave it like this. But this right here will kind of tell you if it's bouncing on a graph, whereas here it might be a little bit harder to see. So that is how you factor a monomial out of a cubic. Now if we'll continue, someone, don't know who, came up with this cool pattern that will happen every single time. So it is called the sum or difference of 2 cubes. We kind of talked about the difference of a square, and now we're going to talk about the difference of 2 cubes. So here is your pattern that will always happen. So if you are adding 2 terms that have cubed, this is always going to be your answer. If you're subtracting 2 cubed things, this will always be your answer. So let's take a look at this. First one, I've got a subtraction, so I'm going to be following this example down here. Now, 125 does not have a cubed exponent. So what you have to do is ask yourself, what number cubed is 125? So what number times what number times what number is 125? And it's a 5. So 5 to the 3rd power, 5 times 5 times 5 is 125. So it's actually kind of nice if you remember some of these numbers for common cubes. So 1, you can cube it because 1 to the 3rd power is still 1. 2 is a nice number because 2 times 2 times 2 is an 8. 3, you can also cube it, would be a 27 because 3 times 3 times 3 is 27. 4 can also be cubed. So 4 times 4 times 4 is 64. So these are some nice cubes to kind of memorize. Once you get kind of over 200, we don't like to memorize them. But 1, 8, 27, and 64 are some common cubes that you will see. So we've got 125. I've got a subtraction problem, so let me follow this formula. My A is the first term. So in this problem, it is x. My B is my second term. In this problem, it is a 5. And I'm going to take this A and this B and plug it into my formula. So my formula says I'm going to have 2 parentheses. The first parenthesis is your A minus your B. So I'm going to say x minus 5. Because your x was your A your b was 5. My second parenthesis is your a squared. My a is just an x and then squared. I'm going to put a plus sign. It wants me to multiply a and b. So I'm going to multiply x and 5 to get a 5x. And then plus my b value squared. My b value is a 5. 5 squared, 5 times 5 is 25. So here is my answer to factoring a difference of 2 cubes. Okay? So the bad part is you kind of have to memorize this formula if you want to use this shortcut. Let's do another one. On part E, I have an 8s cubed and then a 27. So like I said, I need to figure out what number to the third power would give me an 8. So if I go back to my little shortcut here, I know 2 to the third power is going to give me an 8. So I'm going to change this problem 2s to the third power because 2 to the third is an 8 and s to the third is a s cubed. Plus, I need to ask myself what number cubed is a 27. If I go back to my table, 27 is 3 to the third power. So 27 can be written as 3 to the third power. So now I can find my a and my b to plug it into this shortcut. So my a is going to be 2s. My b is going to be 3. So it is the base of your exponent. And now we're going to plug it in to this top formula because I have a plus. So I'm going to have 2 parentheses. Your first parenthesis is your a plus your b. So my 2s and a plus 3. My second parenthesis is my a squared. This is a little tricky because I've got 2s and I need to square both of them. So we'll talk about that. Then I'm going to subtract my a term times my b term. So I've got 2s times my b term, 3, and then plus my b squared term, which is 3, so 3 squared, and close it. The last step is just to simplify this out. So your first parenthesis drops down. 2s squared. So 2 squared is 4, and then s squared is s squared. So that's how we simplify. Minus 2 times 3 is 6, so 6s, and then 3 squared is 9. And so that is our answer of factoring the sum of 2 cubes. Okay? So thank you for watching part 1 of factoring cubics. You are now going to head to part 2 on how to factor some more problems. Let me know if you have any questions.